Hello to everyone. This is the third lecture on system programming where we are going through the machine structure, machine language and assembly language. So this is our lecture outline where we will study the general machine structure or architecture, then general approach to a new machine. Then general machine. General machine is nothing but a von Neumann machine, which we have discussed in the first chapter, that a computer system mainly consists of a memory, a arithmetic logic unit is there, and central processing unit is there, a processing unit is there, memory is there, arithmetic logic unit is there, and a control unit is there, and input output ports are there. So in this lecture we will mainly focus on the IBM 360 machine instructions, structure and language. The CPU, the whole course we will study the IBM 360 machine. Okay. The CPU mainly consists of an instruction interpreter, a location counter, an instruction register, and working registers and general purpose registers. So the whole architecture is called as a von Neumann machine. Okay. So now we will study what are the functions of these parts or the elements of the CPU. So here you can see a general machine structure is there. Okay. Here you can see a instruction interpreter is there. Instruction interpreter interprets the instruction which is currently being executed or the process which is currently being executed with the help of location counter. Location counter points to that instruction which is currently being executed. Suppose this is a memory and here 0, 1, 2, 3 are addresses, and location counter points to that address of the instruction which is going to be executed next. Okay. So instruction interpreter will interpret that instruction which is pointed out by the location counter. Okay. Here you can see the location counter points to the memory address register. Memory address register is a register which stores the current instruction's address. Then after that you can see a memory buffer register is there. Memory buffer register stores the contents of the memory address register. Then the contents are then passed to the instruction register. Okay, instruction registers copy or it stores a copy of the memory buffer register. Then this data is passed to the working register. Suppose we are adding x plus y. Two variables are added. Okay. Then x is a part, y is a part, and the operator plus is also a part. These instructions are then stored in the instruction register. Then the x part and the y part are passed to the working registers and the plus operation is done there. And after that, whatever result, suppose x is 2 and y is 3, then we will get 5. That result is transferred to the instruction interpreter. Then from the instruction interpreter, the results are passed to the general purpose registers. General purpose register stores the data of the computation, or it stores the output of the data. Okay. So this is the basic structure of a general machine and a CPU. So here are the definitions. You can see instruction interpreter interprets or reads the instruction from the memory. Location counter, or as well as it is called as a program counter or instruction counter, it denotes the location of the current instruction being executed. Instruction register, a copy of content of location counter is stored in the instruction register. Then what is a working register? It is a scratch pad for the instruction register. Then what is a general purpose register? It is used by the programmers as a storage location. Then memory address register, it contains the address of the memory location that is read. Memory buffer register, it contains the copy of the content of the memory location which address is stored in the MAR. Memory controller, it is a hardware device whose work is to transfer the contents of the MBR to the core memory location which address is stored in a MAR. Then what is input output channels, which is connected to the whole system? It separates the computers which interpret special instructions for inputting and outputting information from the memory. Then here we have discussed earlier that we will use the IBM 360 machine instructions. So it is a instruction of a IBM 360 machine. So here you see a instruction is there. For example, the instruction has three parts. Operation code is there, suppose plus or minus into or divide, opcode. Then register number is there. Okay, register are small devices, hardware devices which stores the values. Okay, then memory location is there. Okay, and this is the format of an instruction. For example, if we write like this, add 2,16, that means that we are using the value for addition. The value is now in 176 address and it is loaded into register number 2. Okay, and this is the working of general machine structure, which you can easily verify it from the Donovan book. Okay, this is the flow chart of the general machine structure, which we have further discussed. Sorry, we have earlier discussed. Then the general approach to a new machine. The general approach to a new machine mainly consists of memory, registers, data, instructions, special features. So these are the important building blocks of a new machine. So in the next lecture, we will go through the memory, what is a memory, then what is a register, what are the data we are using in a IBM 360 machine, then what is the instruction format and the special features a general machine have. Okay, so thank you.